Imagine discovering a locked digital file from a lost civilization. Vital information inside, but the password and code are lost. This is the challenge of our digital age puzzles hidden behind complex code. But this isn't new. 2 centuries ago, scholars faced a similar mystery, carved in black granite, the Rosetta Stone. The stone held the secrets of ancient Egypt, locked in a language unreadable for over 1,000 years. Its decipherment was one of history's greatest code-breaking triumphs. The methods used to unlock the Rosetta Stone echo the principles behind artificial intelligence today. Both are about pattern recognition, comparing the known with the unknown, finding clues in vast data. The scholars who worked on the stone were like early data scientists, searching for patterns and entry points into a complex system. Their success laid the groundwork for a way of thinking that powers our technological world. The quest to understand the past and the quest to build the future are surprisingly similar. Both require patience, systematic thinking, and educated guesses with incomplete information. The Rosetta Stone was a message in 3 scripts, a multilingual key to its own solution. It provided the necessary data for comparison, just as modern AI systems are trained on massive datasets. The stone was, in essence, an ancient training dataset for the human mind. As we explore artificial intelligence, it's useful to look back, before computers, algorithms, or the internet. The Rosetta Stone is more than a history lesson, it's a timeless example of how humans solve complex problems. The fundamental principles of code breaking, from ancient hieroglyphs to modern machine learning, remain the same. Every complex code has a key. The challenge is knowing how and where to look. The Rosetta Stone isn't a grand monument, it's a broken slab, found by French soldiers in 1799 in the Egyptian town of Rosetta. Its appearance is unremarkable, but its content is extraordinary, a single message written in 3 scripts. The top section is in ancient Egyptian hieroglyphs, the sacred script of priests, unreadable for centuries. The middle is Demotic, the everyday script of ancient Egypt. Simpler, more cursive but also undeciphered. The third section is ancient Greek, a language scholars knew well. The Greek text was the known quantity, the plain text in our code-breaking analogy. The decree on the stone, issued in 196 BC, praised King Ptolemy V. The importance of the stone was not in what it said, but in how it said it, a parallel text. It was like having a user manual in 3 languages, 2 of which you can't read. The Greek acted as the guide, allowing scholars to assume the other texts were direct translations. This was the starting point for decipherment. The stone was broken and incomplete, with missing parts in each text, but it provided enough data to begin matching words and sounds across the scripts. The presence of 3 scripts suggested language evolution and offered multiple clues. Scholars could now compare, cross-reference, and slowly unlock the code. The Rosetta Stone's true value was as a bridge between the known and the unknown. It was the ultimate codebook for a lost language. With it, the ancient world began to speak again. The process would be long and difficult, but the key was finally in hand. The race to decipher had begun. The first breakthrough came from English scholar Thomas Young. He noticed certain hieroglyphs were enclosed in an oval, called a cartouche. Young guessed these cartouches highlighted royal names, like King Ptolemy. He matched the Greek name Ptolemaios to the hieroglyphs inside the cartouche. Young proposed that these symbols represented sounds, not just ideas, a radical shift. For centuries, scholars thought hieroglyphs were purely symbolic. Young suggested some were phonetic, representing spoken language. He identified several sounds in Ptolemy's name and compared them to another cartouche, likely Queen Berenice. This comparison revealed more phonetic clues. However, Young believed phonetic hieroglyphs were only for foreign names. He didn't apply this system to the entire language. Still, his work was a crucial first step, proving that pattern recognition and cross-referencing could yield results. Young opened the door for further discovery. He had found the key, but hesitated to turn it fully. His insights set the stage for the next leap. The puzzle was ready for a new mind. The final breakthrough came from Jean-François Champollion, a French genius devoted to ancient Egypt. He learned Coptic, the last stage of the Egyptian language, a crucial insight. Building on Young's work, Champollion believed the phonetic system applied to all hieroglyphs, not just foreign names. In 1822, he studied a cartouche with a sun symbol, knowing the Coptic word for sun was Ra. He pieced together the name Ra SS, Rameses. This was the eureka moment. Hieroglyphs were phonetic for native names too. Champollion realized the script was a hybrid. Some symbols were pictograms, others phonograms, and some both. He tested his theory on other names like Thutmose, and it worked. He had cracked the code. Champollion announced his discovery, forever changing our understanding of ancient history. His success was built on years of study, knowledge of related languages, and the courage to challenge old assumptions. The system was more complex and nuanced than anyone had imagined. Champollion's insight unlocked the voices of ancient Egypt. The Rosetta Stone's secrets were finally revealed. This was not luck, but the result of relentless human curiosity. The code was broken, and a lost world was found. The story of the Rosetta Stone became a model for solving complex problems. It showed the power of combining data, context, and creative thinking. The ancient puzzle had met its match. The Rosetta Stone's decipherment is a powerful analogy for how modern AI learns. Think of its 3 scripts as a training dataset: unknown hieroglyphs, related Demotic, and known Greek. This mirrors how machine learning models are trained, especially in language translation. AI systems analyze millions of parallel texts like UN documents to find patterns between languages. The AI doesn't understand language, it identifies statistical relationships. Just as Champollion used Greek as his guide, AI uses known languages to map unknown ones. The Rosetta Stone was a perfect, small-scale dataset for this task. Repetitive names and phrases acted as anchor points, just as proper nouns help AI align texts. Both ancient decipherment and modern AI translation depend on the quality and quantity of parallel data. Without the Greek text, hieroglyphs might have stayed a mystery. Without massive datasets, AI translation wouldn't work. Both ancient codebreakers and AI developers face the problem of incomplete data. The Rosetta Stone is a fragment. Missing sections meant scholars had to infer missing words from context. Modern AI faces similar gaps. If training data is incomplete or biased, the AI's output is flawed. A translation model trained mostly on legal documents will struggle with poetry or slang. Developers use diverse datasets to fill these gaps. AI models also have a context window. They can only consider so much text at once. If key information falls outside this window, errors happen. Scholars had to keep the whole decree in mind, not just translate word by word. Both must deal with ambiguity. A single symbol or word can have multiple meanings. Champollion had to decide when a symbol was a picture or a sound. AI must learn that bank can mean a financial institution or a river's edge. Solving this requires more than data. It requires understanding context. The struggle with incomplete data connects ancient and modern code breakers. In language, context is everything, true for Champollion and for AI today. Champollion's deep knowledge of Coptic and Egyptian history helped him decode hieroglyphs. He understood the decree's political and religious context, making sense of otherwise obscure phrases. Modern AI also strives for context. Chatbots look at previous questions to maintain coherent conversations. Ambiguous queries like, "Tell me about the capital," require context to interpret. Translating idioms or cultural references is difficult for both humans and machines. A literal translation often fails. A good translator finds a culturally equivalent phrase. Champollion realized hieroglyphs reflected the Egyptian worldview, not just a code. The Rosetta Stone's decree was full of specific titles and rituals. Context was essential. AI too must understand more than just words. It needs context to provide accurate information. In both eras, accurate communication depends on shared understanding. Context is king in language. The Rosetta Stone and AI share parallels, but the human element is crucial. Deciphering hieroglyphs was a story of curiosity, rivalry, and intuition, not automation. Scholars like Young and Champollion formed hypotheses and made creative leaps. Champollion's connection to Coptic came from passionate study, not pattern matching. His breakthrough was a flash of human insight. AI excels at finding patterns but lacks genuine understanding or consciousness. It manipulates mathematical representations, not meaning. The Rosetta Stone reminds us, technology is a tool, not a replacement for human intellect. Today, AI helps analyze ancient texts, but humans interpret the results. The goal is to empower scholars, not replace them. The quest for knowledge is deeply human, driven by our desire to understand. The Rosetta Stone symbolizes that quest and the power of the human mind. As AI grows, its purpose is to augment our humanity, not diminish it. The story is about human ingenuity, aided by powerful tools. The Rosetta Stone story is more than history. It echoes in our AI-driven age. It teaches that communication is about building bridges across minds, cultures, and eras. The stone bridged 14 centuries of silence, connecting ancient Egypt to the modern world. Today, technology builds new bridges. AI translates languages, deciphers genetics, and explores the cosmos. In every case, we use technology to find meaning in complex data. The challenge remains, turning raw information into understanding. The Rosetta Stone is both a key to the past and a map for the future. Every leap forward begins with a puzzle and human determination. The methods of linguists and AI developers are branches of the same tree. The world is full of undeciphered scripts. Our quest is to keep searching and building bridges. With the right key, data, and human ingenuity, no code is unbreakable.